In the late 1800s and early 1900s, a brilliant scientist named Albert Einstein was making waves in the world of physics. He was fascinated by the mysteries of the universe and was particularly interested in the behavior of light. Einstein began to ponder the question of whether time and space were truly as fixed as people thought. He realized that the speed of light seemed to remain constant, regardless of the motion of the observer or the source of the light. This led him to develop his theory of special relativity, which he published in 1905. In this theory, Einstein proposed that the laws of physics are the same for all non-accelerating observers, regardless of their relative motion. This means that if you and your friend are moving at different speeds, and you observe the same event, you will both see the same thing happen. This might seem like common sense, but it was a revolutionary idea at the time. To explain his theory, Einstein used the example of a train moving at a constant speed. If you are standing still and observing the train, you will see that the clock on the train is ticking slower than your own clock. This is because time appears to slow down as an object moves faster. Similarly, the length of the train will appear shorter to you than it does to someone on the train. Einstein's theory of special relativity challenged the commonly accepted notions of time and space, and paved the way for his later work on the theory of general relativity. In this theory, Einstein proposed that gravity is not a force, but rather a result of the curvature of spacetime caused by the presence of mass and energy. To understand this concept, imagine a large object, like a planet or a star, sitting on a flat sheet of rubber. The object will cause the rubber to curve and warp, creating a dent or a well in the rubber. Now imagine rolling a smaller object, like a marble, along the rubber sheet. The marble will naturally move towards the larger object because the curvature of the rubber sheet creates a slope. This is similar to how gravity works in the universe. The larger an object's mass, the more it warps the fabric of spacetime, and the stronger its gravitational pull. Einstein's theory of general relativity has been confirmed through numerous experiments and observations, including the famous 1919 solar eclipse that provided evidence for the bending of light by gravitational fields. This was a major breakthrough in the field of astronomy, as it allowed scientists to measure the mass of distant objects, like stars and galaxies. Einstein's ideas were not always immediately accepted by the scientific community, and he faced criticism and skepticism throughout his career. However, his work has had a profound impact on modern physics, astronomy, and cosmology, and continues to inspire ongoing research and exploration in these fields. Perhaps Einstein's most famous equation is E=mc², which expresses the equivalence of mass and energy. This means that energy and mass are interchangeable, and that even small amounts of mass contain a tremendous amount of energy. This idea has been used to develop nuclear power and atomic bombs, and has had significant consequences for the world we live in today. In conclusion, Albert Einstein's work on the theory of relativity was a groundbreaking achievement that challenged commonly accepted ideas about time, space, and gravity. His ideas have had a profound impact on the fields of physics, astronomy, and cosmology, and continue to inspire ongoing research and exploration in these areas. Einstein's legacy as one of the greatest scientists of all time will live on forever.